Okay, hello. So this is a video on how to do some questions from exercise 3G that you wanted extra feedback on. Brush size. Okay, exercise 3G questions 3 to 9. So I've got them up on the right and I'll go through them on the left. So exercise 3G is all about solving inequalities. So quickly just to go over that, if we have a axis, okay, and we're given some quadratic, it might be, what's this, x squared plus 2x minus 3, it might be something like that, okay, and we want to know when that might be less than 0, okay, that might be that. So what we have, we're wanting to know when the y value of that quadratic is less than 0, and as we can see from the graph, okay, along here our y value is less than 0. Okay, so the solution for this inequality here would be when x is, this is b. If I factorize this quickly, x plus 3, x minus 1, yeah, that's the factorization. So over here, that is x, that's negative 3, right there, that is 1, okay, so between the two intercepts is when this function is less, when the y value is less than 0. So we could say when negative 3x is between negative 3 and positive 1, okay. Now what happens though if we change this to including 0? We want to know when this function is less than or including 0. So we want to know when the y value is less than or including 0. So that means we now get to include our intercepts. So we would say that's include. And then if we change this again, okay, we did the exact same equation, x squared plus 2x minus 3, and we want to know when it was greater than 0. Okay, well now that is this zone out here. Okay, so the y values at that stage are greater than 0. So we would say that is for x less than negative 3 or x greater than positive 1. So when we're doing any of these inequality questions, you need to be able to graph the function and actually visualize what's going on. So there's two main steps. One, you need to factorize because you need the intercepts. Okay, and then once you have the intercepts, you can graph to visualize. Okay, so step 1, factorize to find the intercepts. 2, graph it to visualize. So you guys asked me to go over some questions from question 3 to 9. So let's do that. So let's have a look at question 3a. So we have 5 minus x plus 5 is less than 0. Okay, so the nice thing about question 3, that very first one, it's already factorized. Now the thing to note from all of the question 3 problems is they have a negative x squared term, okay, or some of them they have a negative y squared term. But either way, they have a negative squared term. That means instead of being a standard parabola in that form, they're going to be flipped upside down. Okay, so x squared negative x squared means they're flipped upside down. So you have to remember that when you're graphing them. So this one, okay, using the null factor law to find the intercepts. And I find it's handy to go back to the original null factor law, especially when you have a negative x inside here. Okay, so we have 5 minus x is equal to 0, or we have x plus 5 equal to 0. So we get 5 is equal to x, or x is equal. So we have our two intercepts, so we're going to do a quick sketch. Okay, so -5, 5. Okay, and now I know when we're doing proper sketching questions, when we're asking a sketch, we always want to label all coordinates in coordinate form, but just for a quick little sketch to visualize, we don't have to worry about that. We can cheat a little bit. Okay, so this graph is going to look something like that. Terrible drawing, sorry, on my tablet today. Okay, so we want to know when this function is less than 0, so we care about this zone here and this zone here. That's when our y values are less than 0. Okay, so it'll be x less than -5 or x greater than 5. Okay, in either of those two zones, this function will end up less than 0. So all the rest of the questions in exercise 3 are exactly the same. We'll do, just to show you, let's do question 3D. So we have 36 minus 25x squared greater than or equal to 0. Okay. So first thing I notice here is we have the negative x term. Here we've got a 36 and 25, both are perfect squares. So this is actually a difference of perfect squares. So we can use our shortcut. If we have a squared minus b squared, something squared minus something squared, that factorizes to a plus b, a plus b. So we can use that shortcut straight away because this is the same as 6 squared minus 5x all squared less than or greater than or equal to 0, sorry. So we can then factorize it just like this. Something squared minus something squared. So we get 6 minus 5x plus 5x greater than or equal to 0. So using the null factor law, we have 6 minus 5x 0 plus 5x 0. Therefore, x2 is on 5 or negative x on 5. Do a little sketch. Okay, now again it's a negative, so it's going to be up this way by 2 points. That's going to be negative 6, 5, 6 on 5, and we want to know when our y value is greater than or equal to 0. So that's going to be for this zone in here, and it can include 0, so we get to include our intercepts. So we get x is between and including negative 6 on 5 up to 6. Cool. Okay. Let's move on to question 4. Okay. So question 4, we will have a go at, let's do 4a. Start with the first one. Okay. So solve each of the following inequalities. X squared plus 2x minus 8 greater than 0. Okay, so we need to factorize. So it has no coefficient in front of the x squared term. I'm going to try and factorize via inspection. So factors of 8 that add to give 2. So that would work as x plus 4, x minus 2. Yeah, positive 4 times negative 2 gives me negative 8. Positive 4 minus 2 gives me 2, so that works. Greater than 0, so we can say for our intercepts, x equal to -4, 2. And this is a positive x squared term, so we can quick graph here, positive 2 there. It's going to look something like that. Okay, and we want to know when that is greater than or equal to 0. So we care about this zone here. That's when our y value greater than or equal to 0. And same over here. So x is less than or equal to -4, or x is greater than or equal to 2. And we include the equal to because we get to include our intercepts because it's y greater than or equal to 0. I'm pretty sure most of the problems through question 4 are going to be exactly the same. Having a look at, say, 4D, you'll need to factorize that by cross method or the quadratic equation, since it's got a 2 in front of x squared. Looking like, say, E, G, and those ones, you'll need to rearrange them so it's saying something, so it's greater than or equal to 0 rather than greater than or equal to 6. So just rearrange those. So we'll have a go at question 5. Solve the following inequality. So x squared plus 3x minus 5 greater than or equal to 0. So same thing, going to try and factorize via inspection. Only factors of 5 is 1 and 5, and there's no way I can get 1 and 5 to add together to give me 3, so that doesn't work. So the next thing I'm going to try is by completing the square. So, and that's a 3, so half 3 is 1.5, or 3 on 2. So remember, when we're completing the square, we take this number in here, our b number, and we halve it and square it and add it on, and then so it's going to be 3 on 2 squared. Might leave it in that form. And 5 greater than 0, so we get this x plus 3 on 2 squared minus 3 on 2 squared. 9 on 4 minus 9 on 4 and 5. And this is where you shouldn't be afraid to scribble. At times like this when I'm recording, it might be terrible in arithmetic, so I'm happy to scribble. So to turn 5 is the same as 20 on 24 greater than or equal to 0. We get x plus 3 on 2 all squared minus 29 on 4 greater than or equal to 0. So write that as x plus 3 on 2 all squared minus the square root of 29 on 4 squared. And now we have our difference of perfect squares, which is the point of completing the square. This is looking yucky, so this is another time when you could have just used the quadratic formula. Because we get x plus 3 on 2 minus the square root of 4. X plus 3 2 plus 29 square root 4. So that's the same as I don't know why my pen size is big. So it's going to be the same as 3 on 2. 20 on 2. It's really weird why that's going large there, but anyway, I'll keep going. X plus 3 on 2 plus 2. So you can keep going and then we get an estimate. So we get 3 minus root 22 x 22. So square root of 29. This is a great trick to help estimate where these are roughly. Not that we need to, but it's going to be 29 is between root 25 and 36, 5, which is 6. So this is going to be 5 point something something. So this will be a negative number. So we can do a quick sketch. 3 minus 5 point something, that's going to be there. And we have 3 plus 5 point something, that's 8, which is there. And this was a regular quadratic, so it's something like that. And we wanted to know when it was greater than or equal to 0. We cared about that zone there and that zone there. So it's going to be x is greater than or equal to 3 plus root 29 on 2, or x is less than or equal to 3 minus root 29 all on 2. That's going to be a negative, isn't it? I made a mistake there. Yep. Well, I shouldn't record videos so late. Okay, let's scrap that a little bit. Done this wrong. Okay, because I've instantly read that as a positive number that turns to negative when we take away that, because this whole thing is going to come to negative something, but it's a sign there, and when we use the null factor, well, that gives us a positive. Okay, so the intercept is there and there actually. This is x. Hold on. Let me think for a second. That becomes a negative. So how can I write this as a positive? I'll just leave it. Oh, it's negative 3 plus, yeah. Oh my god. That's going to be x is equal to negative 3 plus root 22, which gives you positive, and this is the x negative 3 minus. Like that. There we go, that's better. X is equal to, sorry, x needs to be greater than or equal to negative 3 plus root 29 on 2, x less than or equal to negative 3 minus root 29, 2. That's what happens when you skip steps. I just took that and I was reading off it, being lazy. Okay. that was, what was that? That was question 5A. Same deal for all of those. It's just having to use a more complex method to factorize. Be careful. I'm gonna skip, actually no, I'll do question 6 and then I'm just gonna skip down to question 8, because if you can do question 6, you can do 7. If you can do 8, you can do 9. No idea why that pen. Okay, we'll keep going. So, question 6. Explain why x minus 3 all squared is greater or equal to 0 for all x. Okay, so x minus 3 all squared greater than or equal to 0 for all x. Well, we've got a square here, so no matter what we put in here, if this ends up as a positive, doesn't matter what number we choose for x, but if this ends up as a positive squared, that's going to equal positive. If we put a if whatever x we choose, but if this whole thing ends up becoming negative because we square, it's going to be equal to positive. If we put a 3 in there, 3 minus 3 all squared, that's going to be equal to 0. So it doesn't matter what we choose to put in here, whether this all ends up whatever x, but if this all ends up positive, well, squaring becomes positive. Doesn't matter what choose x, if this whole thing becomes negative, squared, it's going to become positive. Or if we choose a 3, we put a 3 in here, 3 minus 3 is 0, all squared is 0. So this will always be true, because whatever we get here, whatever x value, it doesn't matter what we choose, because we square it, it always ends up positive, so our y will always be greater than or equal to 0. And question 8 is going to have a very similar theme. Okay. Complete the square for x squared plus 2x plus 7, and hence show that x squared plus 2x plus 7 is greater than or equal to 6 for all x. So what the hell's going on here with this greater than or equal to 6? Well, let's do the complete the square. So x squared plus 2x plus 7. Okay. That's going to be the same as x squared plus 2x, halve the 2, which is 1, then square it. 1 squared is 1, so we get plus 1 minus 1 by completing the square, plus 7. Okay. So we now get x squared plus 1 all squared plus 6. Okay. Plus 6. Okay. Now we could say the same sort of thing is going to go in here. I put that as a squared. That's not a squared. X plus 1 all squared plus 6. Okay. That is exactly the same. Okay. So we have the same sort of issue up. Okay. If whatever I put in here, any value of x, okay, this whole thing, doesn't matter if it's negative, okay, or positive, because it's squared, it's going to turn into positive. So this whole thing, okay, for any x plus 1 all squared is greater than or equal to. And then because we're adding 6 to it, okay, so whatever we get here, that's always going to be equal to or greater than 0. Because we're always adding 6 to it, we can follow on, okay, for any x plus 1 all squared plus 6 has to be greater than or equal to 6. Because whatever we get here is greater than or equal to 0, because we're adding 6 has to be greater than or equal to 6. If we keep going, if we think back to its original form, okay, these two equations are exactly the same, we can say x squared plus 2x plus 7 is greater than or equal to 6. Question 9 is going to be exactly the same. That's it for those. I'll leave it at that. If you have any more questions, ask me in class.